Hello everyone, I'm Bingzhe. Welcome back to another video. So in this video, we're gonna be moving through the last part of chapter 4. So in fact, this will be the last video for chapter 4. And our agenda for this video will be uh, angles, steel angles. Alright, so number one will be, oh no, not this color. Number one, we'll be going through angles in a semicircle. Alright, there's actually one type of angles in semicircle that you need to take note of. And number two, we'll be talking a little bit about tangents and radius. You know, the relationship between radius and the radius of a circle touching the tangent, touching the circumference of a circle. Alright, then after that, we'll be looking at angles subtended. How do I spell this? T-E-N-D, subtended by same arc. Yeah, this is something that you will need to know. I mean, you need to pretty much know everything here. Yeah, it's pretty popular in IGCSE exams, especially this angles chapter. So please make sure that you understand and you are familiar with all these. And after that, we will look at cyclic quadrilateral. All right, and last but not least, for this chapter, we're going to be looking at alternate segment. Yeah, so this alternate segment is different from the alternate angle that I mentioned from the last video. So yeah, let's move into our first agenda for today. Angles in the semicircle. So there's nothing much actually for angles in the semicircle. So let me write down the topic: angles in a semicircle. So if I'm gonna draw a semicircle right here, just to check my mic is not muted. Okay, this is a semicircle. Definitely not. Let's look at this shape right here. Can I get some smart drawing? Where is the shape right here? Okay, I'm just gonna make another circle right here. Okay, great. So if we're gonna draw a semicircle right here, which we were gonna divide this, this is the radius, and I'm gonna divide this. Very great. Okay, so as you can see here, this is a radius. I mean, this is a, let's say it's a diameter. All right, so this is a diameter of a circle, and this point here is touching the circumference of the circle, same as this point. All right, so the diameter touching both sides of the circumference. Okay, so if you have this kind of situation right here, together with any triangle, all right, any triangle in the semicircle. All right, let's say you have this, you have this, and you have something like this. All right, so if you have a triangle in a semicircle where the base of the triangle is the diameter touching the circumference of this touching the circumference at both ends of the semicircle of the circle, then this angle right here is a 90 degrees. Okay, so this is the one and only rule for angle in a semicircle that you will actually need to know. So yeah, so just to repeat, if you have a triangle inside a semicircle where the base is the diameter passing through the midpoint of the circle, touching both ends of the circumference, then this angle right here, all right, you see, if you see this triangle, this angle right here is a 90 degrees. All right, and these angles you can find from using other properties that we are going to see in the next video, in the next slide, or from the previous videos. All right, so yeah, we are done with the first agenda. It's just that simple. And let's move on to the second one, where we are going to look at tangent and radius. So basically, if I'm gonna erase this, right, this is change the color and say this is the radius. Okay, so the tangent, as mentioned from a lot of videos of mine, the tangent is a line touching only one point. Okay, so in this case, the tangent is only going to touch the circle at one point, which is right here. I don't actually consider, okay, something like this. So this is a straight line. All right, let's consider it's a straight line. So this is a tangent. All right, this is a tangent. Did I see something about my microphone? Okay, so this is a tangent and this is a radius. So when there's a radius from the midpoint of the circle touching the circumference, and there's a tangent touching at that point, then this angle right here is a 90 degrees. All right, it can work on any other places where you have a radius right here. This is another radius. All right, and this is another tangent line. Okay, this is another tangent line. Then this right here is a 90 degrees, which means this is also another 90 degrees. So this is all you need to know about the second agenda, where we talk about tangents and radius. It's just the relationship between the radius and the tangent. All right, so next we will move on to something harder, which is angles subtended by the same arc. All right, so let's first write down the topic here: angles subtended by same arc. And you might be wondering, why are there two circles? Because there are two different cases. So number one, okay, what does the arc mean? From the previous video, the arc is like, there's like this circumference place. All right, this is the arc. If you're gonna draw a sector, then that's the arc. So at this part here, the shape goes like a butterfly. All right, so from this point right here, I move to two places, and this two joins at the same point, and the other one will go something like this. Okay, so this is how, as you can see, from the same arc, all right, from the same arc, then this two right here has the same theta value. Okay, it's just that simple. All right, so if you have other thing, these two may not be parallel. Okay, they don't have to be parallel, but if they are from two same points, okay, moving up, so as you can see the structure here, it looks like a butterfly. So this two is the same angle. All right, and we call this angle subtended by same arc. However, what's the second circle for? The second circle here is for the angle between the angle at the center. Angle at the center is twice the angle at circumference when they are subtended by same arc. All right, so I'm gonna just convert this. Just give me a second. Okay, and this is angle subtended by same arc. Okay, so what is this meaning here? Angle at the center is twice the angle at the circumference. Okay, so this is the midpoint of a circle. Okay, let's change the color. So if you have from the same 2 points here. You go to the circumference, all right? And from the same 2 points, you move to the midpoint. Okay, so if you have a shape like this, all right, or any similar shape like this, then let's say this is theta, then this will be 2 theta. All right, so the angle at the center of the circle will be twice the angle at the circumference. All right, and in fact, you don't need to have the same shape like this. If you have something like, let's change the color, something like this. All right, this is also theta, because from it, as you can see from here, this 2 is what we had shown, all right, from this previous one, angle subtended by the same arc. All right, if you can see the difference. All right, so yeah, this is all about the angle at the center is twice the circumference and subtended from the same arc. All right, so yeah, you need to remember this property because it's quite important, and they usually like to ask this a lot. Okay, next we are going to move on to cyclic quadrilateral. All right, so I prepared all the circles here just to minimize the time wasted from you looking at me drawing the circles. So this is we're gonna say cyclic quadrilateral. All right, so as the name suggests, cyclic, I mean, I don't know why the name is just like that, but I would say if you imagine it like in a circle, all right, and quadrilateral is just a four-sided shape, all right, so the whole name suggests a four-sided shape inside a circle where all the corners must touch the circumference. All right, so I will just draw a random one here. Okay, so I'll just draw a random one here, like this. I use a different color, this one, and maybe something like this to make it more like an irregular, yeah, to make it more like an irregular quadrilateral so that it's better to show. Oh no, it's so hard to draw a straight line here. One last try, yeah? Okay. So this is a typical cyclic quadrilateral that you will see, where you can see this is a quadrilateral and all the corners here are touching the circumference of the circle. So what properties can we get here? So let's name all the angles here. Let's name this as A, B, C, and D. Okay, so if you get something question like this, during my time, I like this property the most because it's the easiest. So what does the cyclic quadrilateral suggest is the opposite the opposite angles add up to 180 degrees. All right, so the example right here that we can see, the cyclic quadrilateral here suggests that A plus C will be equals to 180 degrees and B plus D will be equals to 180 degrees. So the opposite sides will add up to 180 degrees and this as well. All right. And there's one last property here that you always need to remember since it's a quadrilateral. Okay, A plus B plus C plus D must always equals to 360 degrees. All right, and it actually proves that A plus C is 180 and B plus D is also 180. And when you add all of them, it's 360 degrees. All right, so this is all about cyclic quadrilateral. I always like to see this when it comes on an exam because it's just easy. All right, and we're gonna move on to the last part of this video. It's actually faster than I expected as compared to the previous video. This last one here, we're gonna be looking at alternate segment. Alternate segment. Alright, I don't know how to explain this name right here, but all you need to know about alternate segment is when you have a triangle and a tangent. So just give me some time. I'm gonna draw the triangle right here. This triangle right here. Okay, and there is a tangent and there is a straight line right here. Just can't draw it nicely. Yeah, okay. So if you are to name all the angles inside the triangle, let's say this is A, this is B, and this is C, then and then you have a line right here. It's a tangent touching the circle. So if you let's say have like a midpoint, you dot it down, it will be something like 90 degrees. But I would not include that in this diagram. It will just make it more messy. So what you will need to remember is if this is A, then this part is A. This part will be A degrees. All right, and same thing, this part will be B. Okay, so there is, I don't actually read through what is the reason of this, but how I remember it was, if you see the angle A right here, okay, this part is occupied. Therefore, this angle right here will be A. All right, as you can see, it's further away from A. If I draw a line right here, A is here, so it's nearer to this angle. Therefore, this angle cannot be A, because if this is A, meaning this must be parallel to the tangent line, right? That makes the alternate angle. However, it's not. So if you draw like a line right here, the A takes the region right here. So this angle outside the region will be A. All right, I hope you can get it. So it goes the same as B. B takes the region, right? The angle B here takes the region right here. I mean, if you can understand. Therefore, the B will take the region here where it's not the region of the B inside the triangle. All right, so I hope you can see it. So to give more examples here, I am going to draw another tangent line here. All right. Okay, just assume that this is a nice, smooth, straight tangent line, okay, without this thing. So you can give yourself a little bit of time to pause this video and see which part here is angle B and which part here is angle C. All right. Once you are ready, here we are. As you can see here, B takes all the B is at nearer to this region right here, which means this part cannot be B. So this is B. All right, and C will be this part. All right, and to prove that this is actually correct, A plus B plus C are the sum of interior angles of a triangle must be equal to 180 degrees, right? Which means this is a straight line. A plus B plus C is also equals to 180 degrees. Therefore, this is correct. All right, so you can always double check with angles. That's why I say angles is a kind of fun chapter if you know all the properties of them, so that you can actually double check from using a lot of different methods to make sure that you are correct. All right, so you can actually draw one more line here to see this part is angle C and this part is angle A. All right, so yeah, with this I conclude that this is the end of chapter 4 about angles. So there are a lot of angles actually requires a lot of practice. All right, so by just watching these videos about theories, it can't really help you much. So I suggest you to do a lot of past year paper on that, and I might bring through a few questions when I'm going through the past year papers. All right, so yeah, just to recap, in this video, we had gone through angles in the semicircle, all right, which is basically just the 90 degrees rule, and then the tangent and the radius, the properties right here is 90 degrees. After that, we have this angle subtended by the same arc, and then from the middle of the center of the circle is twice when it touches the circumference. All right, this is important, yeah. Next, we have cyclic quadrilateral, where the opposite adds up to 180 degrees. And last but not least, we have alternate segment, which is just a random rule right here that you just need to remember. Okay, it will actually help you a lot in when you are solving questions. All right, so yeah, this is all about chapter 4 and about this video. So I hope you guys understand, and I'll see you guys next time.